AI beats humans at chess, writing, diagnosis. So why can't it fold laundry? Some problems look easy, but hide deep complexity. And cracking that code is key to understanding how far we are from true general intelligence. In this video, we'll explore where AI excels, where it stumbles, and what that tells us about the future of AGI. Back in 2021, Priya, a robotics engineer in California, saw a demo of OpenAI's Codex and thought, this will replace my junior analysts. But a year later, she was still fielding endless requests from the same AI, unable to trust it with real engineering judgments. It wrote code impressively, but floundered without clear instructions. Her story is a glimpse of a pattern we see again and again. Highly specialized AI systems outperform humans in tightly constrained tasks. They are amazing at chess, Go, protein structure prediction, even real-time image generation. But these are narrow tasks with bounded rules and goals. Outside those boundaries, the magic evaporates. Consider GPT-4, rated at the top percentile in many academic exams, yet it lacks consistent reasoning and can contradict itself moments later. It can ace a legal test if you give it multiple choice, but struggle to plan a picnic. So why does this happen? Because current AI systems are hammers looking for nails. They require data-rich environments and well-labeled feedback loops. But general intelligence, the kind humans possess, thrives in ambiguity. It adapts in novel situations, learns new tasks without retraining, and connects abstract ideas creatively. That's what makes AGI, or artificial general intelligence, such a towering challenge. Human infants learn through messy trial and error. They interpret body language, infer intentions, and generalize quickly. Today's AI doesn't. It mimics intelligence through brute force, not deep understanding. Still, progress is undeniable. Transformers, diffusion models, and reinforcement learning have all pushed the envelope. Yet, for every milestone AI hits, it also exposes its own boundaries. For instance, robots can do backflips, yet fail at folding towels. Why? Because sensing soft, manipulable objects in imperfect environments remains one of robotics' unsolved problems. The physical world is noisy. Context matters. And that's exactly what current systems lack: contextual depth. The dream of AGI implies fluid intelligence across many domains, not just performing, but understanding tasks as diverse as conversation, navigation, judgment, and adaptation. What keeps it out of reach isn't speed or data, but architecture. Our best tools, deep neural networks, are statistical engines. They compress correlations, not understanding. They lack goal awareness, memory fidelity, and the rich mental models humans build over years. As exciting as ChatGPT or DALL-E may seem, these are not steps toward consciousness, but better autocomplete machines. Some researchers believe we're decades from AGI. Others suggest we're inches away. Part of the tension comes from unclear definitions. Is an AGI something that passes benchmarks across fields? Or something that understands intent, emotion, self? Benchmarks like the Turing test, once a gold standard, now feel outdated. Chatbots pass them, yet remain clueless about the world. The truth may be that AGI isn't a finish line, but a spectrum. We inch forward by layering capabilities. Multimodal models that see, hear, and speak show promise. They connect different sensory domains. But coherence still breaks down under stress, or when asked to pursue long-term goals. For Priya, the choice became clear. Use AI to amplify, but not replace, her engineers. The best results came when humans guided the system and interpreted its quirks. And that's perhaps the wisest takeaway. AGI might not suddenly arrive like an awakening robot. It may be something we cobble together, incrementally, cautiously, never crossing a sharp line, but waking up one day and realizing our tools have become broader than we thought. The question isn't just when AGI arrives, but whether we're ready for its shadow. Subscribe to explore how